Okay, this lesson is for Wednesday, and this is section 14.3, sine and cosine as coordinates. All right. Um, Essentially what we want to be doing in this lesson is determining how we can use sine and cosine, our trig functions, representing coordinates. So we're going to be looking at some right triangles placed in the coordinate plane. Okay. Step one, the first thing we're going to do is we're going to look at a right triangle, ABC, that is placed on a coordinate plane. So the first thing we want to do is we're going to draw our coordinates, just to x, y. Make sure you label everything. This becomes y and x. And we want to look at the right triangle ABC with the vertex B at the origin. Okay, so that's B. We're going to draw a right triangle. Right triangle is represented by this square. Okay. And the vertex of the right angle C on the positive x-axis, which means this becomes C over here. Okay? We'll call this A. So triangle ABC. B, the coordinate is 0, 0. A, the coordinate is A, B. And C, the coordinate becomes A0 because we're not going anywhere in the y direction. All right. This is our angle that we're going to be talking about, and we're going to represent this with theta. This is something that should be review for all of you. All right? Step 2, a unit circle which is a circle with radius of length 1 and the center at the origin, the point 0, 0, is placed over triangle ABC. Since, actually let's draw it before we actually discuss it. So we're going to draw our coordinate again. This is y, x. We're going to draw our triangle. So right triangle, A, B, C. This is the point 0, 0. Okay, so when we discuss this, we're talking about superimposing. When I say superimpose, I mean we're drawing a circle over our triangle. And I'm going to have to cut down into what I'm writing. I apologize. So a unit circle says it has a radius of length 1, which means half of it is going to go from here to about here if we call this 1. Since this is the radius, this is half, diameter would go all the way across to about here, which could be 1 on the other side. It also has a radius of 1 going up and down, so it's going to be about here to here. So we're going to superimpose this circle over our right triangle. It's not a very good circle, I apologize. Okay? So this is a unit circle, which means this point here becomes 0, 1. This point here becomes 1, 0. Negative 1, 0. And 0, negative 1. Okay? So, we place the triangle over the unit circle over ABC. Since BA, right here, I guess you can't see me doing this unless I draw. BA intersects the unit circle at point P. I'm going to represent this with P. BP, line segment BP, which is right here, is a radius of the circle, and BP must equal 1. Okay? Then PQ, we're going to call this PQ, is drawn perpendicular to the x-axis at Q. Okay? And this also represents a right triangle. All right? Give you guys a second to get that down. I know I'm going kind of fast. Okay, we've got one more step. Step 3, points. Hope you're going to be able to see this. I'll do it in black so you can see a little bit of a difference. Points P of XY and Q of x0 and b of 0, 0 are the vertices of the right triangle with BP equal to 1, BQ equal to x, and PQ equal to y in the right triangle PBQ. PBQ. Okay, so what this allows us to do is it allows us to come up with our trig functions. We can say sine of theta equals, and you guys should know this, sine is opposite over hypotenuse. And in this case, it equals y over 1 or y. This is the proof for what we really want to get out of this, okay? And cosine of theta equals adjacent over hypotenuse, which equals x over 1 or x. All right, so the main point of doing this all out is to show us one thing, the coordinates of P. And in this case, and in every case, xy, when we talk about our trig functions, it equals cosine theta, sine theta. So when we're talking about an xy point, when we're talking about trigonometry, we can use x equal to cosine and y equal to sine. Okay? Next page.